What is up, everybody? How's it going? So, today we're going to be talking about parsing a module declaration. The last couple of episodes, I've kind of been talking about setting up the parser and what an AST is. So, today we're actually going to have our first episode where we start getting into the actual parser. So, the first thing you'll want to do, if you remember before, we had this parse method, and that's effectively what gets called. And we have a ton of functions to create. The way that I'm going to do it is I'm just going to do it on a case-by-case basis. It's impossible for me to go through all the functions at once because I'd have to explain everything. So we're just going to, as we go through the parsing process, explain what each function does and why we need it. So the first thing we want is we want to, of course, or we want to first check to see if our tokens has a size greater than 0. So what that does is that checks the tokenizer and that returns a long from this function called size, and it's just a quick way to check the size of the token. So if we're processing a file that has no tokens, we obviously don't, there's nothing to parse, so we don't need to do anything. Otherwise, we want to set the source file to the actual file from the tokenizer. And like I said before, this is very inefficient, so I'm actually going to just delete this. And in the spots where it's actually broken, I'm just going to go and fix it. So tokens.file. So you just want to be able to get the file name at certain points in the code. That's kind of the main purpose for it. So you want to set up your error management system. So you want to set up a new error manager. And in there, pretty much every time we set up our error management system, it's going to be pretty straightforward. So it's going to be the same every time for the most part. So you need to pass in the lines that the tokenizer found. You need to pass in the file, whether or not you're printing errors as is. Now, this is important. So I have a concept in my error management system where I can print out errors as is, which means that as the errors are getting printed or as the errors are being found, it doesn't try to do any like weird wizardry where like I can effectively queue up a bunch of errors that are pending to be complained about. And if I decide that, oh, well, I don't want to complain about those errors, which we'll see in a little bit how that works, then I can dump all of those pending errors and just ignore them. As is, it's just going to always print out the errors as they come along. So parsers are very complicated. So just make sure that when you're processing your error management system or when you're setting it up, you want to make sure that you have a way where it can pretty much queue up a bunch of errors to be printed at a later time. After that, we want to set whether or not the user set aggressive error flag to true in our options menu. Next, we want to set our current. So we want to set our current token or our current token. So this is just a pointer to the tokens list. It's a lot faster doing it this way, so that's why I did it. After that, we want to have our panic flag. So we want to check to see if our panic flag is set to true. If so, we want to break out of this while loop. It's just going to loop forever. So the only time when we break out of this is if it's the end of the file, obviously. Otherwise, we just want to keep looping. So you want to be careful. Just make sure that you've covered all your bases. And eventually, we'll get to it a little bit later, but it's very important. You're going to eventually want to have a parse all. What this function does is I can parse tons of things in my language. I have my grammar file, which is right here. And I can parse a ton of different things in my parser. It's going to be able to process statements and declarations and so on and so forth. You want to eventually have a parse all function, and this is required so that way we're not looping forever. All right, so after that, you want to create a function called isAccessDeclaration. So I created this little current define statement here, which basically just dereferences current. So our current token is a pointer. So maybe we want to actually use this as just a normal value where you can use the dot because C++ and its syntax, it's a pointer, you have to do that. So that's just something I added. It's not really necessary. You can just probably pass in the pointer if you want, but I just want to explain that. So basically what this takes is this takes a reference to a token, which again I probably should just put the pointer there, but it's fine. And it checks to see if our token is an access declaration. So okay, so I just made a quick change to this function. I realized it's pretty inefficient. So what I'm going to basically be doing is you want to check to first see if the token is an identifier. If it's not an identifier, then we just don't care. After that, you want to check to see if the token value is equal to any of these. So in our language and also in our grammars file, we want to basically specify anything that is an access specifier, is it? So here it is in my grammar. I call it an access type. I renamed it to access specifier, so that's fine. I just haven't updated the file yet. But basically, you just want to check to see if you have public, static, private, protected, stable, extension, constant, and local. So all of these are considered access specifiers. Public, private, and protected. I'm going to assume you guys know what that is. Also static as well. But we do have some ones that I feel that I need to explain. So we want to have our stable, which basically means that you can't modify the class. So eventually we'll have extension functions in our class or extension functions in our programming language. And what this flag does is this prevents people or users from adding on extension functions to your class. This ext or extension access declaration, it basically just means that we can't instantiate the class. And to better explain it, this is basically just like abstract from Java. So yeah, that's a pretty good comparison for what this means. And then finally, constant, which is pretty straightforward. Oh, we also have local. But constant just basically means constant. So it's a final. It's like final in Java. Um, and finally, local. This one's new. This one basically means that we want to define something local to a file. So we can have local functions where that function can only be accessed and called within the file that it was created in. We can also create local classes, local fields, basically anything. So that's what that is. After that, let's scroll down. So once we've determined that it's an access declaration, then we want to parse an access type. So we want to parse through all of these because remember, like you can have a class. So like I can have a class here. So I have like this class house. Um, let's say public, um, stable, extension class. So like I can tack on a bunch of access declarations here that specify this is how this class should be accessed. So we want to just add up all of those basically. So this function is going to be pretty easy. So if I go back up to the top, we go here, it literally is just a while loop and it just keeps checking to see if the current token is an access declaration and then it adds it to access type. So this is important. It's not adding these tokens to any specific AST, and there's a very good reason for that, and we'll get into that in a little bit. But you basically want to have a list of access types where you're storing it. Now, if you want to talk about efficiency, because I know you guys are going to mention it, a better solution for this is to create a pointer. So, because right now what I'm doing is every time when I add this to this list, I'm effectively copying this address and putting it inside of this list here. So it'd be probably better to just have like a pointer and then just directly put underscore current in there and it'll be a reference to it instead of copying the data. But that's what I'm doing. And then after that, you want to advance so that way you're not like while looping forever. So let's go back. After that, you want to check your error limit. This is a standard that I have in all of my functions, well, most of them at least. And all that does is it's just a define which quickly checks to see have we panicked. If we have, run the exit procedure. Otherwise, if our errors and we get the unfiltered error count, so this is like the raw count of all of the errors that our compiler has found, then we want to, and we also want to check to see if it's greater than the error limit. And what that is that's just the options error limit here. And if it is, then set panic to true and do the exit proc. So what the exit proc is each function is different. So like some functions return like booleans or whatever. So like I can return like false here. So I can basically just put whatever statement I want in there. So that way, if it turns out to be false or true or whatever, then it can do the appropriate thing to exit out of the function. After that, we want to check to see if we're at the end. So I basically check to see if the current, and I get the type of the current token is equal to end of file. Then if so, then that means we're at the end. Next after that, all right, so now we want to actually parse a module declaration. So we're going to first have our function here where we check to see if it's a module declaration. So we want to see if it's an identifier and it's equal to mod. So that this is the actual lettering or the syntax for module declarations. So I'm going to just kind of delete all this. We want to basically parse this code here. So we're going to say mod main. So we first check for this, and then let's go back. So once we do that, we want to say if access types, if the size is greater than 0. So again, this is why I wanted to put it in this list and not put it in the actual AST, because there are some cases where you're not supposed to have access types. Like it doesn't make sense to have a public module. So we want to check that, and if so, we want to say illegal access declaration. And if we remember, this is an actual pre-populated error. So if we go here to our error management system, it'll already print out the error and say illegal specification of access specifiers. So if that is the case, then we print out that error and we continue on. You don't want to like skip over, you just want to complain to the user. So that way we can continue processing it. After that, you want to create a branch off the current AST. So if you guys remember before, I was talking about how every AST has branches and they have several ones. Well, we need to create this get branch function. So in here, what we're going to do is we're going to create a new branch, and it's just going to be a new pointer to a new AST, and we pass in all the information. So we pass in the type of the AST that we pass here. We also want to pass in the current token. So we want to get the current token, we want to get the line of the current token. So where's this current token located in terms of the line, and where's the column? After that, we want to check for something very important. So we want to check to see if our AST is equal to null. And basically what this is if we pass null here, we're basically telling we're telling the parser that we're at the highest level, which means that this basically represents the parent. So here, I'm actually going to change this name to parent. So if the parent is equal to null, then we want to push back the tree. And originally I had like this concept of an AST cursor. This is completely unnecessary, to be honest. Basically, all you want to do is you want to return the last AST. So I'm going to return tree dot last, and you want to return the last AST in the list, which will represent the AST you want to branch down from. Otherwise, if parent is not equal to null, then we just want to add it to the list and return that branch that we just created. Once we do that, we now have created successfully a module declaration branch. And as you can see, I am passing null here because we're at the top level. So we're at the top level of parsing everything. So there should be no parents at this level. So we want to pass null here for that, which will then create us a fresh branch. So once we do that, then we want to expect an identifier from this branch. So we want to pass in the AST, we want to advance. Now here's something important I want to note. The way that the expectation of my parser is that we parse things in a concept of peaking. So basically, let's say we wanted to process this main. That means that we're processing this behind the actual like value. So if we're going to check for an identifier, the current token at processing that is going to be before the main. So we want to check this, we want to advance basically, check to see if this token is what we're expecting. If it is, great, continue. Otherwise, bounce back and create some type of error or something like that. So that's going to be the expectation, and we'll see more of that as we go along the parser. But I just want to put that out there. So after that, we want to check to see if it's an identifier and it's not a keyword. So we want to get the value of our current token. Now, I have a ton of keywords. I'm not going to go through all of them. And we'll run through all these keywords anyway on a case-by-case basis. Like once we start processing statements, there's like if, while, catch, else statements here. So as we start to process things in our language, we'll run through these keywords anyway. So it doesn't make sense to go through them now. But you can see this here, and if you guys want to copy it or whatever, then you can definitely check that out. After that, we want to check to see, so if our AST is not equal to null, we want to add the token to the current token. This is important. It's just a safety check. It's kind of unnecessary, but yeah, it's just a good practice, just to make sure you don't screw yourself over by adding it to a null value. Once we add the token, then we return true and say that we have in fact expected an identifier. Otherwise, we want to return false, um, and we want to error out. So we want to say expected identifier here, and we just pass in the current token, which basically the error management system derives the line in the column from the actual token. So now if we go back to parse module, once we expect an identifier, then we want to peek forward one character and we want to check to see if it's a dot. After that, we want to expect the dot, and what this is this is a universal expect function. So what it basically does is it advances forward, and again, it uses that peek mentality where if I'm expecting something, I want to jump forward, expect that value, and handle it accordingly. So I advance forward one character, which all it does is it checks to see if, this is important too, it checks to see if the current type is not equal to end of file. Then we advance forward one character. That way we don't like run off the end of our pointer from plussing it until the end of time. Once we advance, then we want to check, we want to get the current value, we want to check to see if it's equal to the string that we passed in. If so, then we also want to check a boolean called add token and expected string. So I set up some defaults here. So we want to add the token by default, and we want to set the expected string to a null pointer. Because typically whenever you're expecting a certain token, when it comes down here to error out, typically the error that you want to process is the thing that you're trying to expect, right? So if you're going to expect a dot, or like this, for instance, this right here, you're going to expect it to print out an error expected, whatever the string is. But just in case I wanted to expect one thing and then print out something else, then I added that option. Otherwise, if it's an error, then we check to see if the expected string is not equal to null, and if it is, or if it isn't equal to null, then we print out whatever our expected string was. Otherwise, we just print out whatever the token was and say expected whatever. After that, we want to expect a semicolon. So once we do that, we pretty much say add token is false here. Now, if you notice, if you remember, so add token is set to true by default. There's certain cases where you just don't want to add a bunch of tokens, like because this takes up memory. So as you're building your AST, you want to be mindful of the memory that you're taking up, because compilers, it will get away from you very easily, but compilers can be very big memory hogs, and you want to bring down the memory footprint on the compiler as much as possible. A perfect way to test the performance and the memory hogness, for lack of a better word, of your actual compiler is to run this on a Raspberry Pi. And when I started to test this programming language on Linux, that's what I did. I ran this compiler on a Raspberry Pi, and it showed me how much strain it was putting on the system to actually process things and to compile the actual program. So just keep that in mind, but we do need this dot for processing later, so that's why I decided to keep adding it to the actual AST. And yeah, that's pretty much it. So that's how you parse a module declaration. And it's hopefully that was pretty easy for you guys to understand. So we're just going to continue going on in the YouTube series, and I'm just going to show you guys episode by episode how to parse various different things. So hope you guys enjoyed the video. As per usual, here I'm going to go to my actual GitHub page. Definitely check out my repo. This is the actual repository where the language is developed on a daily basis. Definitely check out the remastered branch. This one's the most up-to-date, and I usually update this one pretty frequently. Anything other than master or remastered or stale, so definitely don't check those out. Also, if you wanted to stay a little bit more up to date in terms of the plans that I have for the future for this language, or maybe things that I've did in the past, definitely check out the doc folder. You can look at the change list file, which will lay out all the different things that I've added to the language currently and changes and updates to it. And then you can also check out the roadmap file, which basically lays out everything that I've either done to the language or things that I'm looking to add to the language. So hope you guys enjoyed the video today. Definitely like, comment, and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.